Cloud computing has become a real buzzword these days. It refers to computing and processing done online on remote servers rather than on a device itself. Despite its sky-high name, this computing is not done in some mystical clouds. Instead, it's done in a very terrestrial data center inside a dedicated building. However, this could change in the near future. We are not going into the clouds, no. But rather, we are taking the opposite route and heading into the sea. Yes, you heard it right. Tech giant Microsoft is testing out the possibility of putting data centers underwater. At face value, this may sound like a ridiculous idea, but after all, electronics and water go together like cats and cucumbers. But Microsoft begs to disagree. Based on the recent internal research conducted by Microsoft, the best place for a data center is underwater. Yes, as you dig deeper, you see that this revolutionary idea is pretty clever. So let's find out today what are the main reasons that Microsoft is moving their data centers underwater. Let's also find out when this was started and what are the advantages of having data centers underwater. Microsoft started this journey as early as 2014 in a project named Natick. As part of this project, in phase 1, the engineers understood how to move data centers underwater. In phase 2, they turned the design into production. And the site chosen for this phase was the North Sea near Onquay in Scotland. Microsoft underwater data center in the North Sea contains 864 servers and 27.6 petabytes of memory. This data center was tightly packed in steel containers filled with dry nitrogen and submerged in the icy choppy waters of the North Sea in 2018. Now let's find out why they did that. Electronics is not really meant to work in an environment where humans live. Things like oxygen and moisture are in the air, which aren't good for electronics. These substances lead to corrosion and ultimately cause server failures. With no human presence, there is no chance of anyone inadvertently bumping into things, which often leads to accidental failures. So one of the main basic reasons of putting a data center underwater was to create a relatively stable environment so that computer servers can perform better and last longer. Traditional land-based data centers consume a considerable amount of energy just to keep the servers cool. Older data centers use mechanical cooling, using heavy-duty air conditioners for cooling, which consume a lot of power. Underwater data centers can simply use the surrounding water to transfer heat dissipated from the servers. Just think of a swimming pool on a scorching summer day. The swimming pool water stays relatively cool as compared to the concrete deck next to it. As land-based data centers are located in remote, less than accessible regions, the data that you require for communicating online needs to travel a longer distance, which in turn means lower computing speed. But nearly 44% of the world's population resides within 150 km of a shoreline. Thus, it makes better sense to place data centers close to the coast. When data centers are dumped just off the coast, they will be close to the areas with relatively higher population density. This cuts down the average distance between the server and the users, thereby mitigating latency. So, underwater data centers are likely to make the cloud computing experience even snappier. It turns out that it could be faster to build a bunch of watertight pods and then submerge them into the sea, rather than acquiring land and building a data center from the ground up. When constructing a data center on land, you require real estate, which is often costly, and then companies need to evaluate the feasibility of other conditions such as topography, availability of skilled labor, reliable electricity, compliance with local and legal rules, and so on. Server pods needed underwater operation can be built in an assembly line fashion and then shipped for deployment onto the sea without any hassle. That it can set up these server pods in just 90 days. Compare this to a 2-year required to build a land-based data center. If you like the video, don't forget to like, share, subscribe and comment in both YouTube and Facebook. The channel needs your support to grow. Thank you.